equations. Just as a quick review, what we've already done is first we just looked at, in 12.1, quadratic equations that had perfect squares that we could solve. On Friday, we looked at completing the square. So again, to solve quadratic equations. Today we look at a third method called the quadratic formula. And what this is a formula that you're just going to plug numbers into. First of all, let me just, so you have it in your notes, let me just remind you again of the overall pattern. Whoops. Oh, geez. And I just wrote that badly, so I'm going to start over. Put the wrong letter. ax squared plus bx plus c. Okay. So, starting with this, we looked at this last week for the completing the square. Remember that this means the a, the b, and the c would actually be filled in with actual numbers. So thinking of that pattern, here is the quadratic formula that you are going to be using. Now, later on you're going to get to choose what method you want. If you like this method, that's great. Now, x equals. X meaning that you're solving it. What we were doing with the completing the square and lesson 12.1 as well is we're trying to find what x equals. Not x squared, but plain x. So the formula shows the x already here. You're not plugging anything in here, right? In the problem, it will be an x. There's nothing to plug in. So just know this is showing, hey, this will give us the answer for what x is. X equals, now be careful here, there's a lot of details, minus b plus or minus the square root of b squared minus 4 times a times c, and that whole thing over 2a. Now, I know it looks like a beast. It's not going to be that hard once we start. Let me just point out, before I'm going to tell you a little story in just a second, let me just point out, anywhere there's a b, it comes from here, this number. Anywhere there's an a, it would be this number, and c, the plain number. Now, I had a friend who used to teach math at South City High, and one of her students came up with a little story for the quadratic formula. You don't have to memorize this. You get to use your notes. However, with my little story, some of you will be able to memorize this formula. Here's how the story goes. There was a negative boy, who couldn't decide yes or no whether or not he wanted to go to the radical party. I'll start again. There's a negative boy who couldn't decide yes or no whether or not he wanted to go to the radical party. He decided to be square and stay home, and he missed out on 4 awesome chicks. Right. And the party was over at 2 a.m. I know, it's such a good story, I'll tell it one more time. There was a negative boy who couldn't decide yes or no if he wanted to go to the radical party. He decided to be square, he stayed home and missed out on 4 awesome chicks. The party was over at 2 a.m. It's a good story, huh? Don't clap for me. Don't clap for me. I didn't make it up. Shh. If you are lucky, I will not make you memorize this formula. If I decide to give you a pop quiz on the formula, just remember the story. Negative boy, couldn't decide, radical party, b squared, stayed home, missed out on 4 awesome chicks, it was over at 2 a.m. Done. There's the story. Now you know the quadratic formula. It would be very hard to memorize without the story. The story makes it a little simpler. Here's how you use it. All you have to do is plug in the a, the b, and the c. For example, if we have 9x squared plus 12x minus 1 equals 0, and you are asked to use the quadratic formula to solve. My a is 9, my b is positive 12, my c is negative 1. Make sure you're taking a look at the signs. As you plug it in, first of all, let me point out, this one's in the right format already. We've got everything on the left side equals 0. If it does not look like this, now it could also be the 0 on the right and the whole rest of the problem, I'm sorry, the 0 on the left. So you could have 0 equals here and then all of this. The point is though, all of this needs to be together on one side. This has it. If it didn't have that, you have to get everything together on one side so that it equals 0. And I'll show you that in just a second, but I just want to point out this one's already in the right position. Everything's together. Here's my A, my B, and my C. I work with the formula, x equals, that's what I want to find, negative B. Now this negative is part of the formula. The boy was negative. That's why he didn't go to the party. He's stuck home being all emo. He was negative that day. So the negative, if this was a minus 12 here, guys, you'd have negative and negative, which would make a positive. In this case, the minus part of the formula, but it's a positive 12, so I end up with negative 12. Be careful if you have double negatives, right? If the B is a negative and there's a negative in the formula, those would make a positive. Negative 12, negative boy, couldn't decide, plus or minus, to go to the radical party. He decided to B square. Well, maybe I can do some mental math here. B squared, 12 squared, 144. Minus, always a minus. Always 4 awesome chicks. 4 times A times C. Now here's where we got to pay attention again with the signs. It's a negative C, a negative 1. All over at 2 a.m., 2 times A, my A is 9. So you just have to go carefully, look at the formula, tell yourself your little story if you want, and now we just have to follow PEMDAS. I'm going to start underneath the radical. I'm going to leave everything else up here. Now, 144, let me leave that alone. I have to do all this multiplication before I can do anything else, all of this, right? All multiplying has to happen before subtraction in PEMDAS. So I'm always going to be multiplying the 4, the A, and the C, the 4 awesome chicks. I'm going to be multiplying all those numbers before I do anything with the B squared. Negative times negative, I get a positive. So 36 times 1, 36, but negative times negative, positive or plus 36. You have to be careful with your signs. 2 times 9 on the bottom, 18. Now again, I can start to simplify within the radical. 144 plus 36, 150, 180. And down in the bottom, we'll just leave it as 18 for now. Okay, now, I don't need you to get decimals. You can leave it as a radical. Let me double check. Yep, you can leave it as a radical. Now the book says then approximate it to the nearest 10. You don't have to do that part. We'll leave it as a radical. I do need to simplify, however. 180 is not a perfect square, but what is in there that is a perfect square? Okay, good. We could change it, thank you, to whoever that was back there, to 9 times 20. Perfect square of 9 is perfect square of 3 times 3. So I have negative 12 plus or minus 3 root 20. Now this is still all over 18. So I'm just working on this radical part here. Everything else is the same. Now the 20 could also be, instead of 20, we could do this as 4 times 5. And the square root of 4 is 2. 2 times 3, that 3 was already there. Right? Square root of 4 is 2. 2 times 3 is 6. I still have the root 5. So before I finish up the problem, because we're almost done, we have one step left. Before I finish, any questions about where any of those numbers came from? Because I took a couple little shortcuts there. Daniel?
Where did the 6 come from?
The square root of 4 is 2. 2 times 3, 6. Okay, so I took that 20, I just didn't write it as a separate step, Daniel, but factoring 20 to 4 times 5, the 5 stays underneath, square root of 4 is 2. 2 times 3. Okay, any other questions about where the numbers came from? Last step, any number that's not outside the radical, we can simplify them like we would with a regular fraction. I see that all 3 of these numbers, they all divide by 6. So I'm gonna do that, just the whole numbers that are outside the radical. -12 divided by 6, -2, plus or minus. Oh, 6 divided by 6 is 1. 1 root 5, you can write the 1, or you can leave the invisible 1. 18 divided by 6, 3. There's my two answers, -2 plus root 5 divided by 3, -2 minus 5 divided by 3, or divided by root 5. Any of the whole numbers? Okay. We're not going to do any other full problems. Let me just show you a couple little things to look out for. Here's one we're not going to do, but I just want to show you how it's different, and you would need to do something before you start. Everything's not on the same side for this one. If you get something like this, I'm going to suggest you keep the x squared positive. For this, we do minus x on both sides. We do plus 8 on both sides. On the right side, it all cancels out. On the left side, you just keep it in order. X squared minus x plus 8. And then once everything's together on one side, now we just have to identify what's our A, what's our B, and what's our C. So just to show you, what's my A? Luke.
1.
Good, it's the number that's in front of the x squared, it's my invisible 1. What's my B? Jaden.
-1.
Good, the number that's in front of the middle x, the variable, negative invisible 1. And then my C, that one's easy hopefully, 8. So just be careful, it could be a 1. Finally, and then you plug them in, you do the same thing. Just work carefully, think of PEMDAS. The final thing I just need to show you, just in case it pops up, if when you're doing this part of the radical, if you get a square root that is a negative, for example, let's say you do the b squared minus 4ac and you end up with a negative number. Is there any number that times itself makes a negative? No. As soon as you get that, no solution. But be careful. You're not going to really get a lot of those. In fact, once I give you the homework assignment, I'll tell you if there are any. There might not be any. I'll have to look and see. There may be none. So I will tell you how many there are, but that's the only way you could get a no solution is with a negative under the radical. Okay?